So in this lesson, we're gonna look at these problems right here, and then we're gonna continue to see what we're gonna summarize here. So in this first paragraph, we're gonna see it says to explain the phenomenon. So and I want to understand each sentence as we read, right? I want to try to understand each sentence, right? This is the first sentence, then this is the next sentence, and then so on, right? So let's see. We are going to explain the phenomenon as we go. So let's read the first sentence. As winter changes to spring, so we know after winter is spring, and then the ice on the lake changes to water. So lakes are like a body of water, right? We have like it's not like water, like you can't go into lakes, but there's like lakes like Grand Canyon. I'm not really familiar about Grand Canyon, but I know what lakes look like because I've seen them before. So like I says over here in the phenomenon, it says there's ice on the lake. So like ice, not ice cubes like in drinks, but there's like kind of like ice plates, right? So there's ice plates on the lake, and then it melts to water, right? It changes to water. So over here it says the temperature in the spring is warmer than in the winter. So that's is here over here. The temperature in the spring is warmer than in winter because we know that winter is colder. It could it's possible that it could snow, but spring is something different where you get to it's like warm, right? It's a warm, it's like warm and not like really hot like summer. It's just warm as like like you have like a warmth that's like very cozy. Like you go on a beach and then you can go in spring and it's good for summer though, beach. But anyways, we're gonna go here. It says we know that spring is warmer than winter, right? So as you can see, it says so now that's the end of the sentence. So this whole thing, all this is saying that the season winter it's after spring, right? And then there's ice on the lake that changes to water, right? It melts to water, and then it's saying that the spring is more hotter, like not hot. I mean, like it's more warmer than winter because winter is cold, right? So, are you getting any ideas about how changing temperature affects a substance? So, use the ice cube that we melted. So, let's say you have an ice cube in a glass of drink or something, in a glass of water, a glass of soda. You have like an ice cube, right? And then what you can do is in summertime or in spring, you can go out and get an ice cube if it's hot. You can go out and get a ice cube and put it outside. If you have a patio, then no, don't put it under the patio. Put it outside the patio if you have one. My house has a patio, but I'm telling you, for your experience, go ahead and take the ice. If you don't have a patio, that's good. You can just leave it outside. But what about in a cup? What would you do if you had it in a cup? Would you like get a heating fan? Would that do anything? I think that take like couple days. Would you go? What would you do? Would you go in a washing machine and put the ice in there? I don't think you would do that, right? You would go outside and do the same thing. You would take a cup, put it outside. Let's say we have so we have that, but we want to know. Let's say we have like a little Let's say we have like a bead, right? We have like some beads. I'm just giving an example. Maybe it won't happen to you guys, but I'm just giving an example. Let's say you have like a little bead or a little piece of gold that's inside the ice cube. What would you do to get that bead out? Would you break it or something? Would you keep stepping on the ice? What would you like throw stones at it? What would you do? Would you like throw rocks? Would you like throw the ice everywhere? I mean, no. I don't think like I don't think your parents would like that. I don't think do something good that's not too aggressive. What would you do that like you would do to like get that bead outside of the ice? What would you do to get that bead outside of that ice cube so that you can like take it out instead of like trying to use your strength and like break the ice and take the bead out? Would you do that? Well, I think the best thing to do, so what you would do is put it in a cup so it doesn't just go on the ground. And then what you can do is just put it in a cup because the floor is dirty, right? So what you can do is just get a cup and put the bead inside the ice, right? Let's say it just like popped up in there, right? You put like there's like a beads in the cup, right? You were about to like put ice in there, and then all of a sudden it went in the ice. You would go put it in the cup and then like go outside with spring and go outside spring or winter. Summer, and then like put it outside your patio. No patio, no like cover, no veranda. Don't put it in there. Put it outside the veranda or your patio. And then what you can do is go ahead and take it, put it outside in front of the sun, and then you're gonna see that the ice melts, and then see, since the ice melted. When ice melts, it means the ice is not there anymore. It becomes smaller and smaller, and then you have the bead. It's like cracking an egg out, and then you have that thing out, right? Just like that. And when you have like that thing, then what you can do is you can go ahead and take that bead out and do whatever you want. And say, oh yeah, dad, mom, I got this bead out that you were looking for. It was inside the ice, so I had to go out and put it in front of the sun so it can the ice can melt. And then and then maybe your parents can say, oh, good idea. Very thankful, very thoughtful of you, something like that, right? So maybe that's that's an example. And it says to use the ice or the ice cube on the lake to make a claim. So the ice cube on the lake is already on. So lakes are always outside. You can't have a lake inside indoors, right? Lakes are always outdoors, in front of mountains, in front of grass, in front of a beautiful place. I don't know, wherever. Like maybe it's close to the Golden Gate Bridge. I don't know. Maybe San Francisco has a lake. We don't know where. We don't know exactly where lakes are. But I've seen one before. I can't produce a name for you, but I know I've seen a lake before. And then that comes about where the lake, so ices are outside, right? And then why did it melt? Because the sun is melting that ice that's on the lake. So when there's ice on the lake, then that means that it's going to melt and add more water to the lake, right? So it says we're going to make a claim about the effect that changing the temperature has on substances. And then now we're going to read the question. It says, what effect does changing temperature have on a substance? So I want to show you one simulation, and then we're going to summarize that simulation. So here's an example of what we see here. Let me make it brighter for a second. Okay, so now we have, let's say, so here, I want you to make a note. So you see, these are called particles. They're like little particles, right? And why are they moving so slowly? Are they actually just sitting there and say, okay, let's just stay here? Are they deciding what they want to do? I don't think so. They're because these particles right here show that they're close together. The more colder it is, like when it's solid, when something is solid, then that means that the particles, so here's what I want you to know. So we know that solid has a definite shape and a definite volume. So when these are they're close together, when they're very close together, we know that ice cubes, they're solids, right? So that they come close together and they're very hard, right? They're really what do you call it? They're kind of tightly packed, Why don't we play? So we have neon, which is something like this. We have argon, we have oxygen, and we have water, which is H2O. I'll explain that in a second. So a neon is like this, right? So we can choose anything, right? We have this is liquid and this is gas. Whoa, what happened all of a sudden? Why is it like this? All of a sudden we put gas? Because the particles, it doesn't have a definite shape, nor does it have a definite volume. So when they're like that, then that means that the particles are going to move far apart. They're not tightly packed. They're not top of each other, trying to spend time with each other. They're okay, let's go apart because there's gas, right? So this gas is it's gonna go. So let's not start with gas yet. Let's start with the solid that's like this. And then let's add heat to it. Okay, it's already cold. We don't need to add more coldness to it. All we're gonna do is just add more heat and see what happens. Okay, so now first it was at like around 20 Kelvin, and then now I fast forwarded it. I put it like around I think it's like 200 Kelvin right now. So I waited like a few seconds to see. I waited like a minute or something, a couple minutes to see if what's gonna happen if we add more heat to it. So right now it's around 300 Kelvin, and I want you to. What do you predict? What will happen? What do you predict? Do you think it's gonna like stay like that? What is getting added to the bucket? What is getting like? What is getting more? What's getting more inside the bucket? What's getting added in the bucket? Is there more particles adding? Is there more air adding? Is there more? Is there more space adding? Is there more color adding? What do you think is more adding? I'll tell you an answer. I want you to tell your parents if it is either what's going on. You can ask yourself what's going on, answer that question, and I'll tell you at the end. So this is gonna keep going, and I'm gonna ask a question after something happens. Watch. And then now finally we have watch. We're gonna see something. Oh, see, all right, there you go. All right, so as you can see, the lid exploded. Does it just say okay? Oh wait, I'm scared of the particles. Let's go because they're like they might bite me. Is that are they like? Do they have a brain that they could say that? Is that something really that they wanted to do? I don't think so. Why did the lid come off of the cap? What do you think happened? I'm not gonna restart it. See, what do you think happened? Why do you think the lid came off the bucket? Is it because I don't know? What do you think? Because there was more added pressure. When there's pressure and it keeps like, and so that we already have everything, and then we can keep doing this, so on and so on. You know, water, it's liquid, right? So water is already liquid. It's not like this where it like comes really close together. I mean, if we add more ice to it, then that's gonna kind of make it just exactly like this, right? Like this, as shown here. But water is liquid, and it's not gonna be like solid, like close and tightly packed. It's not like that. So I was saying we added pressure to this bucket, and I want to go back to that phenomena. I just wanted to show you how the ice is like close together, then it melts, and then you know what I mean. So I was just elaborating how it works out, right? So all right, here we're gonna read the question. What does changing temperature have on a substance? So we just ran through the simulation, the simulation that we just went through, right? So that's what we're gonna use to answer the question. What effect did changing temperature have on a substance, right? We went through the particles, we went through the little molecules, and when we add heat to the molecules or the particles, that's gonna make it move faster, and not faster, and make it like randomly move, like spaced out, and then we have like if it's a liquid, then it's not gonna just go. It's not when it's like not that hot. When it's like cold, then that means that it's like gonna come. When it's not that hot, it means it's gonna like gradually come to the. It's gonna gradually come to the like get tightly packed. So that's like the main thing. That's what the effect has. And then I want you to watch a video. I'm gonna click next. So right here, I'm gonna be clicking next right here, and then we're gonna see the next video, right? So this is the next video, and as you can see, we're gonna watch a video on spring is in the air. We're gonna look at this 13-second video, and then we're gonna see what do we have, and what is our observations in the video? What do we see? So as you can see, the season is changing day by day, right? We have this ice. So as you can see, there's ices here. Oh, and then right here, as you can see, it's getting more warmer. And as you can see, the ice, you can see that it broke apart and melted as it got to spring, right? See, spring is in the air. So spring, when it gets to spring, as you can see, the ice melted and became to liquid. It broke down into pieces, right? See, like that's how it mainly is, right? And this is something that it's very cool, right? And see, as you can see, the ice right here melted and broke apart because there's more heat, right? So, we answered the question. As winter changes to spring, the ice on the lake changes to water. The temperature in the spring is warmer than in the winter, right? See, so we talked about this problem, and we used the question to answer this. And and we have everything, and that's all I have for you today. Thank you so much for watching my video, and I'll see you in the next video.